In this section, we're going to discuss completing the square. In a prior math class, you probably learned a technique called completing the square to solve quadratic equations. Below, you will find a couple of examples of this particular technique. So we're going to use completing the square to solve an equation. So here's our example. We would like to solve x squared minus 6x plus 7 equals 0. This equation does not factor. We could use the quadratic formula, but I want to show you this particular technique. So for step 1, we get the constant term on the right-hand side of the equation. This would give us x squared minus 6x equals negative 7. Step 2, we complete the square on the left-hand side of the equation. To do this, we take 1/2 the coefficient of the x term and then square the number we get. In this case, the coefficient of the x term is negative 6. So 1/2 of negative 6 is negative 3. Squared gives us 9. Notice, by the way, we could have ignored the negative and just done 1/2 of 6 and squared that to get 9. The result would be the same either way. Step 3, add the number found in step 2 to each side of the equation. So now we have x squared minus 6x plus 9 equals negative 7 plus 9. And when I simplify, that gives me x squared minus 6x plus 9 equals 2. Step 4, factor the left-hand side of the equation. If I factor the left side, that will give me x minus 3 multiplied by x minus 3, or x minus 3 squared equals 2. And now we can solve the equation by taking the square root of each side. So when I take the square root of the x minus 3 squared, that'll just give me x minus 3. And then I would take the square root of 2. And then what you need to remember is there are two square roots, both a plus and a minus square root. So we actually will have x minus 3 equals plus or minus square root 2. And then to solve for x, I'd end up with x equals 3 plus or minus the square root of 2. This really gives us the two answers. X is 3 plus the square root of 2. X equals 3 minus the square root of 2, which is the same answer we would have obtained if we used the quadratic formula.